Welcome to the Open Alliance Show. We're so happy to have you back for another year of Open Alliance, and it's one of our most amazing teams that we have here in the Open Alliance. Team Rembrandts coming in from the Netherlands, world champions back in 2019. I remember seeing y'all back then, which I know as students, that's a little past your time, but a team that has continually done so well, and even more so with the Open Alliance Show, and Open Alliance done such an amazing job documenting your progress, showcasing what your team's doing, and your team has done so much so far. We're going to be talking about 3DM, starting out with the data decision making, rapid prototyping, talking about your combined speaker and amp score, and then also talking about your approach to software automation as well too. So we have three fantastic students on from Team Rembrandts. If you don't mind, could you just introduce yourselves on the team, and then we'll hop right into what you want to cover.
Yeah, so my name is Emma. This is my 4th season on the team, I think. And I am the awards lead within the team, and this year I will also be our production manager.
I'm Marjolein, and this is also my 4th year on the team, and I am active in the hardware department.
Yeah, so I'm Corné. This is also my 4th year, and I'm active within the software sub-department.
So we're going to be starting off with what you call 3DM, data-driven decision making on that. So talk to me more about it. We have some cool prototypes I know as well too. We'll be showcasing some screen shares a little bit as well too. But let's start out with your 3DM and tell us more about what it is and how you approach it.
So since a couple of years, we've been doing data-driven decision making. We call it 3DM for short, and it's basically taking like a whole bunch of information from previous seasons, so literally taking data, and from that, like basing our prototypes on that, our archetype for our robot. So we don't just go into prototyping instantly, but we first start with a robot skills list. So actually on the kickoff day, so Saturday, we had kickoff, and then for the Sunday, we made a whole robot skills list. So that's everything that a robot can do within this year's game. It's a whole bunch of things. It's like 50 things or something, I think. And from there, we start looking into previous games. So for example, for this year, we took the 2013 and the 2017 game. And we started like gathering data upon that. So for example, cycle times, and we can make calculations based on that. And for example, from the previous games, with the speed from the robots from that time and the speed that robots have, for example, right now, we could calculate a predicted cycle time. So we would say like, okay, the best robots in the world this year will have a cycle time of around 10 seconds. And then we'll calculate it onto our robots. So we want to have a cycle time of around 12 seconds, for example. What did we do more?
Yeah, we decided which skills were the most important for our robot to have. And then we decide what kind of subsystems we need.
Yeah, so we also made like a list of every possible auto mode a robot could have. So what kind of points could they score? And then we picked out like the modes that we thought, okay, this is something our robot should be able to do, for example. Same with the cycle times in Teleop. So you have like 5 components. So you have like the speaker, you have the amp, you have the trap, you have the climbing, and then you have auto. And then we took a whole bunch of data, and we were just like, okay, to reach a certain goal, so we want our robot to have 70% of the performance ability of like the best robots in the world. So the best robots in the world this year is 100%, and then we kind of like calculate it down to 70%, and that's what we want our robot to be for the regionals that we're going to play. So we're going to California this year again, just like last year, and we want it to be 70% for those regionals. And based on that, we decide like, okay, this is what we're going to do, and this is not what we're going to do. So this year we'll be focusing on the speaker scoring and on the amp scoring.
Looking at that 70% that you mentioned on here, so you mentioned for regionals in particular, when you look at going, hopefully World Championships as well too, does that increase to 100%, or where does the scope or the focus look like for something like that?
I think it depends a bit on how the regionals go, obviously. Like last year, we actually did quite a big iteration for Worlds, but it depends like if it works really well as to how we expect it to work. then I think we'll improve less than if we're saying like, okay, it went totally wrong, and now we're going to improve a whole bunch of stuff. So it depends also a bit on how things will roll out for us.
As we keep moving on, let's talk about some of the other things you've been doing. As I look at your Open Alliance build thread, there's so many just great documentation that's on here from your different types of prototyping you're doing. I know we're going to be talking about CAD as well too, and what you have so far as well. So where do you want to start with? There's so many great things to talk about.
I think the shooter. Actually, we had a bit of trouble with getting our nodes in. So usually we would have some game pieces at kickoff weekend. Unfortunately, due to the international shipping, we had some delays in that. And we didn't know when the nodes were going to come in. So it could either be like 1 week later or a couple of days. So usually we would go into prototyping really rapidly, like more just going hands-on prototyping. But due to the nodes coming in later, we actually took some time this year to make better prototypes. So we actually make prototypes in CAD as well. We wouldn't usually do that in the beginning. So we took a couple of days with that, and we kind of split it up into, we had the speaker and amp combination of a shooter. We had the amp and a trap combination of a shooter for prototyping. And then we had the climber, obviously. So we kind of split it up in that way. And then the first week, fortunately, our nodes came in the Wednesday. So that was 4 days after kickoff. And we had some better prototypes. So we started off with those 3 divisions. And then eventually on the Saturday in the midday, I think, we made a decision on the archetype of our robot. And then we came to the conclusion that we would not do the trap scoring. So we would only proceed with the shooter and the amp scoring. And that's actually a prototype we have over here. So maybe you can explain something about that.
Ja.
Ja, gewoon, how does it work?
Ja, hij gaat vanaf hierin. Die helemaal praten.
Okay, I will talk. So we have the amp and shooter prototype over here. I don't know if you can see it very well. Maybe I should turn it 90 degrees. Something is falling off. We actually just manufactured it. So the idea is that it's one shooter for both the speaker and the amp scoring. And it basically works like this. The node comes in over here. We have a few feeder wheels over here. Those are compliant wheels, 3-inch, if I say correctly. Yeah, 3-inch compliant wheels. And then we can either score in the shooter by directing it, I will pull it straight this way, so straight on. Yeah. Or we can adjust the spinning of the wheels, and it will come over here, and then it will score in the amp. So this is actually our second prototype for this, I think. We removed some wheels, and it will basically be on a pivot. So we will be able to pivot this entire thing and shoot either in the amp or the shooter, or the speaker, I mean. And tonight we'll actually be testing this. So we just manufactured it, and we'll see. I think we'll post about it on the Open Alliance build thread, obviously. So that's how it basically works.
Very cool. Something I want to ask you real quick as you bring up your next thing is you mentioned that you weren't looking at going for the trap on your for your robot. Can you explain a little bit more why you chose not to go that direction?
Yeah, so that actually also has to do with the data-driven decision making. We had some calculations, and for this year we really wanted to keep our robot as simple as possible, not make it too complicated. Also for our students to tag along on the game, like to keep them involved, it's quite hard. And if you're going to make a robot that's really complicated, they won't be able to follow along as easily. So we decided to skip the trap, especially since it's quite a challenge. You have to climb and you have to shoot. And then we would be like, okay, we're going to do everything at once, which we didn't want to. So we chose to skip that one for this year, at least for regionals, maybe for Worlds, but we don't know yet.
Sure. What did you want to show off next? And I definitely want to make sure we get to the CAD as well too, and showcase that.
So we have a few videos. I think we have 2.
Yes.
So this is the video from the speaker shooter. So you see it like being fed through here, and then it's kind of like a laser shot into the speaker, which we really wanted to this year. We really want it to be reliable, and you kind of like need a laser shooter to do that. So this was our first prototype. You see a lot of wheels, you see some belts on the bottom, and we replaced those with wheels this time for the second prototype over here. So we'll be testing that tonight, and then the videos from that will obviously follow. And then we have the amp. It works like this. So usually it will come out at the top, so over here. And now it's just being like bent over into the amp. Works like a charm. It's also being fed from the upper part.
Yeah, from the top.
Yeah, from the top.
So how does that note process or flow get into that area for scoring that way? Like, can you run us through what that transfer essentially kind of looks like?
Like you mean just show over here?
I'm sure, yeah. Just kind of describe it a bit more of how it actually works of getting a note into that space in particular.
Yeah. Okay. So it goes up right like this. So this would essentially be like the pivot point as well. So it would pivot like this. So over like this. And then we have two options. It's either feeding from the bottom, which we can now because it's standing upright, or feeding from the top. So I think it's a bit hard to see. Yeah. Okay, so it's feeding from the top, and then it comes down to around a bit further. It's a bit hard to reach like this. So it would come down to like essentially over here, and then you would turn around the wheels. It's still being stored in here, and when we want to, depends on when you're playing the game, it's being fed up again, which is a bit hard.
Yes.
And then we would also like reverse these wheels, so then it's being pushed into this. No, the other way. Oh wait. Okay, I'm having it the wrong way. Sorry. I will turn it around. Okay, so we have it stored like this in the game, and when we want it to, we will reverse these wheels, and it's basically being pushed into here, which we have some small wheels over here as well, and those will force it into this direction if it's working, but it's a bit hard without a motor on it. So yeah, it's basically stored over here when we want it to.
Sure.
And then we'll reverse wheels and it's being scored.
Two things I guess I want to ask is I'd love to see that in CAD, how that whole packaging works for things, but you have a lot of contact points with the note there as it's going through. Have you noticed any damages to the notes, or how are you trying to mitigate? Because the notes are very pliable, right? But I also, in our testing we've done, they're damaged quite easily through the process.
Yeah, so this has been from so it's now, which day is it? What day is it? It's Tuesday. No, it's Monday. It's Monday. So we have had these notes for 5 days, I believe. No, 5 or 6 days, something. And the wearing on them is quite big. We decided we have a lot of notes, so we decided to have some stored for later on in the season, so when our actual robot is finished. But if you compare them, this is a new note, and then this one is already being used for the entire week, so you see a lot of wearing. And we also noticed that when you squeeze them, the older ones, so the already used ones, are easy to compress, and then the new one is kind of still very how do you say that?
Very airtight.
Firm. Yeah, very airtight still, so you're not really able to squeeze them that easily. So the wearing is quite a lot. It's they damage quite fast, so don't know how we'll see about that. But maybe with this one, especially since we don't have belts anymore, maybe that will make a difference, but we don't know yet.
In just a minute, we're going to get into software automation on your robot, but first, I'd like to jump into your design so far that you have in SolidWorks that you're using for things. So talk to us a little about the packaging of your robot and what that looks like on
there. So we actually have a new program this year, so that we first used Google Drive. Now we are using 3DX. So that the whole team can actually see our robot. So when you want to assemble something, you can easily go to the 3DX site, and you can just move the whole thing and have a look at where you want.
You can look at it.
So for now, this is actually archetype we decided on last Saturday. We decided with the whole team that this is roughly what our robot's going to look like, how it's going to be working. So we have the intake, which is within the bumpers, and then it will store over here. Yeah, maybe point to that. So over here. So it will store at the, wait, it's okay. No, it's a bit slow. Okay, it doesn't like that. Okay, so it will be storing if it's going to be loading. So over here, so we have the, why is it not working as I want it to work? It's a bit rough. It's a big document.
Yeah.
Let me see. Okay, so I think, yes. So over here, it's very hard to see, but this will be the intake. So we can actually drive over a node and then it will automatically intake and it will be stored somewhat over here. So this is like this, where it will be stored and then we'll feed it from here to our shooter. We call it the champer. It's a shooter for the amp and for the speaker. Champer. So it will store over here and then we'll feed it over here. And this entire thing will be able to pivot so we can actually score either in the speaker or in the amp.
Well, looking forward to see that progress on your CAD as well, too. So make sure you do check out the Open Alliance threads and stay up to date with everything that Rembrandts is doing. But as we start to wrap up on this, let's go into software automation. What are you looking at doing this year? You know, there's so many options to look at for something like this, you know, both not just from the autonomous side, but in teleop and how you're doing your transfer process as well, too. So run us through what Team Rembrandts is looking at doing from that approach.
Yeah, so this year we're mostly looking at making it as simple for the driver as possible so that they, for example, for the shooter, have to press one button and everything works by itself. Also for the amp. We're also looking at positioning on the field so that we can set up the robot perfectly for the shot every time. So that we can, with the April tags on the field. There are this year way more April tags than last year, so that really helps with positioning on the field, which allows us to set up way more precise.
And looking at, on your robot-wise, when you're looking into the future for things, can you talk a little about, I know this isn't exactly software animation, but can you talk a little about what you are looking at doing for autonomous? You know, when we brought up that 70% chart earlier, there was a few different options to go with on there. So what is kind of like your primary goal from autonomous? What do you want to accomplish from that perspective?
We really want to get a 4-node auto working. So, just here in the front of the field. We might be able to get a 5-node auto working, but we cannot shoot from really far from the field, so we have to drive a little bit closer, which will make things a bit more difficult, but is fine. And like getting auto working really well, that could be better from last year. So that's something we really want to improve this year, our consistency in auto.
But we're already working on it, right? Because we have a drivetrain that's working right now, so they're already making plots, I believe, right?
Yeah, we're going to work on that.
Yeah, so we're beginning way earlier already with that. So software has already started doing stuff, as opposed to last year, they got time with the robot really late in the season. So we also said okay, in end week 4, we want to have the robot mostly finished, so software can go ahead with it. Driver practice, really important as well. So that also has to do with rapid iteration of design and then finishing the robot as fast as possible, because software is equally as important as hardware.
And that's why we finished the
competition robot.
No, from first itself.
Oh, the kitbot.
The kitbot.
Yeah.
We finished it as soon as possible, so our driver could already train driving with that.
Get a feeling for the game already.
Yeah.
Well,
that was up in, I think, 24 hours.
Yeah.
Very cool. Well, Team Rembrandts, thank you so much for taking the time to tell us about your progress. We can't wait to check back in with you later on the season on the Open Alliance show, but you got to make sure you're following Team Rembrandts both in the OA Discord and on the Chief Delphi blog post and their incredible progress they've been making. So thank you so much. We'll let you get back to work, and we can't wait to see the rest of your progress. Thanks, everybody.
Thank you very much.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.